All right, now we're going to be moving on to hypothesis tests for a population proportion. So this is going to be, again, very similar to what we've already done. We're just going to add step 4 basically to it. All right, so first thing, just make sure that we remember statistically significant. So when observed results are unlikely, under the assumption that the null hypothesis is true, we say that the result is statistically significant and we reject the null hypothesis. So basically what we are trying to show is when we reject our null hypothesis, right, then we are saying that our results are statistically significant. Whatever we say is happening is actually happening, right? Whatever our claim is, it's actually true, right? And we are pretty like 100% certain, right? Statistically significant. We are pretty sure. All of that jazz. So this is what we were trying to show. We were trying to show statistical significance when testing these claims. All right, let's talk a little bit more about what a p-value is. So remember, the p-value is the probability of observing a sample statistic as extreme as, or even more extreme, than one observed under the assumption that the statement is true for the null hypothesis, right? So basically, we're trying to get an unlikely p-value. So another way to say that, the p-value is the likelihood or the probability that the sample will result in a statistic such as the one observed if the hypothesis test is true. So if we did this again, we would expect to get like a similar result if it's true. All right, so for example, and we'll talk more about this, so this won't be the only example we look at. So if our H naught is P equals 0.4 and our H1 is P is less than 0.4, right? So our p-value means that about 19 samples will give a proportion lower or as low as, or sorry, we should say as low as or lower than the one obtained. All right. We'll talk more about that next. And the reason why we said lower, sorry, that comes from our H1, right? H1. All right. Requirements. So there are 4 requirements to be able to do population proportion hypothesis testing for it. First, has to be simple random. Second, we need qualitative data with 2 possible outcomes. Number 3, has to be independent. Or our sample has to work, right? Our formula. So our sample size has to be less than or equal to 5% of your population. Another way we could write that is if we divide our sample size by 0.05, that should be less than or equal to the entire population. And then lastly, we have a formula. So if you notice, these are all the same as our confidence interval for population proportion. This time, it's going to be n times p naught times 1 minus p naught. Has to be greater than 10. Where p naught comes from H naught. So whatever we have in H naught, that's what we're going to use for P naught. All right. And then let's just go through our tests again, our strategy, our steps, our 8 steps. Step 1, we're going to write our claim. Step 2, write our counterclaim. Step 3, do our H naught or our HA. Step 4. So step 4, we need to know what test are we going to use and find the test statistic. So this is basically, when I say test, it's going to be what calculator function are we using. So for instance, for a proportion, if we're testing for a proportion, the calculator, the way that we're going to use on our calculator, we're going to use 1 prop z-test. So you go to you go to stat, over to test. It should be about number 5. 1 prop z-test. So it's where that 1 prop z-int was, right? Now, how do you know we're doing 1 prop z-test? Because we're testing a hypothesis about a proportion. We're testing about a proportion, so we're doing 1 prop z-test. Since it's a z-test, the test statistic in this case is going to be z. Step 5, find our p-value. This is also how we're going to find our p-value. So our p-value will be under p for our 1 prop z-test. Then step 6, find your significance level. Step 7, we either reject the null hypothesis or fail to reject the null hypothesis. Make sure you're writing H naught. And then lastly, write our conclusion. All right, let's go through it. Problem 1. In a research poll, when asked if they felt vulnerable to identity theft, 531 adults said yes and 471 said no. Test the claim that the majority of adults feel vulnerable to identity theft. So first, let's go through our requirements. Number 1, simple random. So it doesn't tell us how they got our people, so we can just assume that it is a simple random sample. Number 2, are there 2 different outcomes? Yeah, you would either feel vulnerable or not. You would answer yes or no. Number 3, let's look at our values, right? So what is our sample size this time? So it's not just the bigger number, it's not 531, it's the combination, right? You either said yes or you said no, so when we add those 2 numbers up, we see that our sample size is 1,002. So the question is 1,002 less than 5% of your population? Which would be everybody, right? All adults. Well, we can divide that out, right? If we divide that out, if we want an exact number, we see that that's going to be about 20,040. So is that less than our entire population? Oh yeah, we definitely have more than 20,000 people in the world, or adults in the world, right? And then number 4, we got to do our formula. So n times p naught times 1 minus p naught. So n we said was 1,002. P naught. So p naught comes from h naught, so maybe it'd be good to actually go through that. So let's do our claim. So our claim is that the majority of adults feel vulnerable. So majority, that's p is greater than 0.5, right? Step 2, counterclaim. P is less than or equal to 0.5. Step 3, H naught, HA. H naught is P equals 0.5 because it's always equals. HA is going to be P is greater than 0.5 because that's where the claim is, right? Or, sorry, the claim in this case has the strict inequality. It doesn't have the equal sign. Okay, so H naught, right? That's our 0.5. So P naught is going to be 0.5, 1 minus 0.5. When we do all that, we should get 120, or 150.5, which is definitely bigger than 10. All right, so we can continue our problem, right? It meets all the requirements. So number 4, what test are we doing? So since it's a proportion, and we're testing a proportion, we're going to do 1 prop z-test. All right, so we got p naught. P naught like we already said, comes from H naught. So we're going to put 0.5. Then we get X. So X is going to be the number of people. Another way to say it, number of successes. Success means we get what we want. So what are we testing for? We're testing that people do feel vulnerable. So how many people said they feel vulnerable to identity theft? We see it's 531. So 531 is going to be our X. That's the number of successes, the number of people who feel vulnerable, the thing that we're actually testing for. Then we got N. We already said that was 1,002. Then it says prop. This means proportion. So basically, is it less than, greater than, or does not equal to P naught? Well, this, just like P naught comes from H naught, this statement is going to come from H1. So you see H1 is greater than, so then this is going to be greater than P naught. So we need to have both of our hypotheses inside our test, right? P naught comes from H naught, and the last statement comes from H1. Or sorry, HA, my bad. Now, some of y'all might be confused because there's a P, but there's a P here, right? So shouldn't that be switched? But remember, P naught is 0.5. So this is just saying greater than 0.5, right? Which is what this says, greater than 0.5. When we plug all that into our calculator, the test stat, that Z, we see the Z is going to be 1.90. Now, don't worry too much about what this Z is. Basically, there are two ways of solving these problems, and one is using a test statistic, and one is using the p-value. Obviously, we do the p-value method, so we don't really need to worry about how to do the test statistic, but homework may still ask for the test stat. So this is an easy way to get some more points on a homework. All right. So let's make some more space. So step 5, p-value. So hopefully we see that the p-value, the p is going to equal to 0.0290. Right? And that's just in the calculator. That's what the p equals. Number 6, our significance level. So, it doesn't tell us what the significance level is, right? So, what can we assume it to be? Hopefully you remember 0.05, right? Assume, since not given. We always assume it's 0.05, excuse me, 5%. Step 7. We see that the p-value is less than our significance level, so we are going to reject. It's unlikely, so we reject our assumption. Because of that, we say there is sufficient evidence, right? There is enough evidence. We rejected it. To conclude that, and what were we trying to conclude? What were we looking at for HA? So HA in this case is the same as our claim, so we just can restate the claim. That's what we were trying to prove. The majority of adults feel vulnerable to identity theft. So that the majority of adults feel vulnerable to identity theft. Good. And that's it. We have proven this. All right, so let's go back to this p-value, right? So we got the p-value was 0.029. So p-value, we said was 0.0290. So a way that we could interpret this, we could say about how many in 100 samples. So if we look at this, right, out of 100, if we multiply that by 100, we would get 2.9. So about 3 in 100 samples will give a sample proportion as high or higher than the one obtained if the population really is 0.5. And again, so if we look at it, right, in this case, the HA was greater than, so as high or higher, that's where that comes from. As high or higher. And then if the sample proportion, H naught, really is 0.5. Number 2. In a survey of 703 randomly selected workers, 61% got their jobs through networking. Use a sample data with a 0.01 significance level to test the claim that less than 70% of workers get their jobs through networking. So let's look at the requirements. Number 1, simple random sample. Doesn't tell us how they got their sample. So we can assume simple random. Number 2, are there 2 outcomes? So either they got their job from networking or not. Number 3, our sample is 703, right? So is that less than 5% of all workers? Yeah, definitely, right? If we want to check, we could divide that by 0.05, which would get us 14,060. Is that less than all workers? Yeah, there's definitely way more than 14,000 people who work. So yeah, we're good there. And then lastly, we got N times P naught times 1 minus P naught. So P naught comes from H naught, so let's do our first 3 steps. Step 1, claim. So the claim says that less than 70% get theirs through networking. So this is a percentage, so we're going to use P, right? So P is less than 0.70. Counterclaim. If the claim is less than, then it's going to be greater than or equal to 0.70, right? Remember, you need the whole thing. You need the P, you need the less than, you need the 0.70. The whole thing is important. All right, we get H naught and HA for step 3. H naught is going to be equal to, because it's always equal. HA is going to be the less than, right? The strict inequality. Good. So now we got P naught. So now we can do the last part of our requirement. So we get 703 times 0.7 times 1 minus 0.7. And we end up with 147.63, which is definitely bigger than 10. All right, all the requirements are done, so we can definitely continue with this problem. So our test is going to be 1 prop z-test, right? Because we're doing a test of a proportion. So P naught is going to come from H naught, so that's 0.7. X is the number of successes. So in this case, we want to know people who got their jobs through networking. So 61% got theirs through networking. So that is a percentage, that is not a number of people, right? So the question is, how many number of people got that? So if it's 61% of 703, right, we can just multiply. And we see that we get 428.83. But since you can't have 0.83 of a person, you need to round that as normal to 249. Sorry, 429. Do as I do, not as I say. Good, so that's 429. If you give me a decimal, if you put a decimal inside this, you will get an error, right? Do not put the decimal in. It needs a whole number. N, we already said, was 703. And then the proportion, right? This comes from HA. So HA is less than, so it's going to be less than P naught. When we plug all that in, we see that our test statistic is negative 5.19. All right, step 5, p-value. So, some of y'all may be thinking that you see the answer, but however, let's think about this. Can a p-value, what is p-value? What does the p in p-value stand for? Probability. Can a probability be greater than 1? No, it cannot, right? So instead, that means either if you have a number for the p-value that's greater than 1, either you messed up, right? Or more likely, you just got to keep looking at the end and see that there is an e negative, right? The negative tells you that you're going to move the decimal to the right, or to the left, excuse me, and this number is going to tell you how many places to move that decimal. So if it's -3, you move the decimal over 3 places. If it's -4, you move it over 4 places. If it's -15, you move it over 15 places, right? But whatever that number is, that's how many places to the left you move the decimal. So when we move our decimal, we should see, if we round to 4 decimal places, right, it's just 0. And if we do that interpretation, right, that means about how many in 100 samples? Well, if you multiply that by 100, right, you just still get 0. So about 0 will give a sample proportion as, so let's look at HA, right? HA is less than, so it's going to be as low or lower than the one obtained if the proportion really is 0.7. So we're not really going to find any more values less than this if it really was 0.7. But of course, as we can see, right, from our number part 6, right, finding our significance level. Significance level this time is 0.01. Since this is less than, we reject the null hypothesis. So we reject our assumption. We reject this. So since this is a really small number, right, this is very unlikely, right? It's not the case that it's equal to 0.7. Right? We reject that. So part 8, since we rejected it, right, then there is sufficient evidence to conclude that, and what were we trying to conclude? Let's look at HA, that our p-value is our proportion is less than 70%, right? That's the same as the claim, so we can just rewrite the claim, right? That less than 70% of workers get their jobs through networking. Good. And we have proven that. All right, number 3. So here's a pretty sad example. So an interesting and popular hypothesis is that individuals can temporarily postpone death to survive a major holiday or important event such as a birthday. So to study this phenomenon, it was found that there were 6,062 deaths in a week before Thanksgiving and 5,938 deaths after Thanksgiving. Okay, so let's think about this. The idea is that you can postpone death right? So you want to, the idea is that you want to see all of your family one more time before you die, right? So if this is true, right? And well, if this is true and arguably people want to see their family, right? They want to have that big event. And that's saying that more people should die after than before, right? You would expect more than half, the majority, to die after Thanksgiving. Which would mean that less than half should be dying before Thanksgiving, right? If this is true, then less than half should be dying before Thanksgiving. So again, that's assuming you want to, do that. So let's use a 0.1 significance level to test the claim that the proportion of deaths before Thanksgiving is less than 0.5, less than half. So we're trying to see if there's any validity to this hypothesis. So requirements. Number 1, it doesn't tell us how they got their people, so we can just assume it's simple random. Number 2, are there 2 qualitative datas? Yep, it's either after or before Thanksgiving. Number 3, so basically, if these are the before and this is the after, we see that our sample size is going to be the sum of them, right? Which we get as 12,000. So is 12,000 less than 5% of your population? So remember, what you can do is you can divide by 0.05 to get 24,000, or 240,000, excuse me. So is that less than N? So in this case, N is going to be, I guess, dying people who are dying. I don't know, right? Is there more than that many people who are dying? I hope not, but maybe. So let's look at the other definition, right? It says it's either this or it had to be independent. Well, arguably, if one person is dying, that wouldn't affect another person dying, right? So at the very least, it is independent. Arguably, one person shouldn't be affecting another person. All right, and then we got our formula. So P naught comes from H naught, so let's do the first 3 steps. Claim. Proportion of deaths is less than 0.5, so P is less than 0.5. Counterclaim. P is greater than or equal to 0.5. H naught, P equals 0.5, because it's always equals. HA, P is less than 0.5. Again, comes from the claim, because out of these 2 statements, that's the only one that doesn't have an equal sign. All right, so now we can do our requirement. So we get 12,000 times 0.5 times 1 minus 0.5. And we get 3,000, which is definitely bigger than 10. So we can continue with this problem. Number 4, what kind of test are we doing? It's one prop z test, right? Because we're testing a proportion. P naught comes from H naught, that's 0.5. X is the number of successes. So in this case, a success is that you die before Thanksgiving. So all the people who died before Thanksgiving was 6,062. N, we already said, was 12,000. And then our statement comes from H1. So it's going to be less than P naught. All right, our test stat is Z is 1.13. Number 5, p-value. So our p-value is 0.87. So if we want to interpret that, right, so about how many in 100 samples? So pretty easy to see that it'd be 87. Will give a sample proportion, is it going to be as high or higher, or is it going to be as low or lower? So if we look at HA, right? HA is less than. So it's going to be as low or lower than the one obtained if the population really is, and that number comes from our H naught. So if it really is 0.5. Number 6, significance level. So significance level, they tell us it's 0.10. Number 7, make a decision. We see that the p-value is greater, so that means that we're going to fail to reject. Which means that there is not sufficient evidence to conclude that so going back, let's look at HA. HA is that P is less than 0.5, which is the same as our claim. So we can just rewrite the claim. So the proportion of deaths before Thanksgiving is less than 0.5. So, what do these results suggest about this phenomenon? Does it work? So remember, we said that if it works, less people should be dying before than after, right? And we just said that there is not sufficient evidence to show that. So what does this suggest about the phenomenon? There's not enough evidence to prove that you can postpone death. Again, maybe you can, but according to our data, not enough information. And remember, so some of y'all might also be looking at the actual sample and you said, well, wait a minute, in the sample, it already was bigger, right? It was more than half. The before was way more than the after, or at least by a couple of people. So couldn't we have just said it at the very beginning? Well, no, remember, this is for a sample. When you're doing a test, it's for the entire population. Just because you have one sample doesn't mean you're going to get the same sample over and over again, right? So we need to make sure that we are looking at it for the entire population, which is why we have to go through this whole process. All right, number 4. In a sample of 167 children selected randomly from one town, it is found that 37 suffer from asthma. At a 0.05 significance level, test the claim that the proportion of all children in the town suffer from asthma is 11%. So requirements. Number 1, doesn't tell us if how they got their people. It just says selected randomly, so we can just assume it was simple random. Number 2, are there 2 different cases? Yep. Either they have asthma or they don't. Number 3. So N in this case is 167. Is this less than 5% of people in the town who have asthma? Well, if we divide by 0.05, we get 3,340. Is that going to be less than, it's just from one town, right? So the population would be everybody, all children. From the town. I don't know. right? It depends on how big the town is. So maybe, but maybe not. But either way, remember the other definition was that it was independent. Is one kid having asthma should affect another kid having asthma? No, right? So regardless, it is independent. And then number 4, we got to look at our formula. So P naught comes from H naught, so let's do the first 3 steps. Claim. The claim that the proportion is 11%. So P equals 0.11. Step 2, counterclaim. P does not equal 0.11. Number 3, we got H naught and we got H1. H naught is equal to, because it's always equal, H1. In this case, we see it's actually the counterclaim, right? It can't have the equal sign. So now we can do our formula, because we got H naught, P naught, right? So 167 times 0.11 times 1 minus 0.11, and we get 16.349, which is definitely bigger than 10. So we can continue with the problem. Number 4, what kind of test do we use? Since we're testing the claim of a proportion, we're going to use one prop z-test. So P naught comes from H naught, so that's 0.11. X, the number of people who suffer from asthma, it was 37. Out of a total of, we said 167. Our statement comes from H1, so we're going to have does not equal P naught. Our test stat, Z, we should get is 4.61. Step 5, p-value. P-value is 0. If you thought it was something else, remember, if it's over 1, you need to look at that E number, right? Move the decimal over, you should get 0. Number 6, significance level. Well, it just told us that it was 0.05. So number 7, reject or fail to reject. P-value is lower, so we're going to reject the null hypothesis. So number 8, since we rejected, there is enough evidence, right? If we ended up having enough evidence to reject it, then there is sufficient evidence to conclude that, now what are we trying to conclude? Let's look at HA. It says P is not equal to 11, which in this case is the counterclaim. So it's whatever the opposite is. So the claim is that the proportion who suffer from asthma is 11%. So we concluded that it is not 11%. Right? So the proportion of all children in the town who suffer from asthma is not 11%. We actually proved that. Now we don't know what it is, but we definitely know it's not 11%. We proved it. All right. Last example. So a cigarette company wants to discredit a nicotine patch therapy. The nicotine patch therapy states that it's basically what helps smokers quit smoking. So in one study, 39 were smoking 1 year after treatment and 32 were not smoking 1 year after treatment. Test the claim that among smokers who try to quit with the nicotine patch therapy, the majority are smoking a year after treatment. So let's look at the requirements. Again, it didn't tell us how they got the people, so we just assume it's simple random. Number 2, are there 2 different outcomes? Yes, you're either smoking a year after or you're not. Number 3. So in this case, we have people smoking after, people smoking before, right? Or smoking after and not smoking after. So both of those would be our N, which would be 71. So 71 less than 5% of all smokers. So 71 divided by 0.05, we get 1,420. Is that less than all smokers? Yeah, I would think there's probably more than just 1,000 people who smoke. That definitely would not be enough to keep cigarettes in business, I wouldn't think. Good. And in any way, right? One person smoking shouldn't necessarily affect someone else smoking. Yeah, I guess it could, right? You could see someone and being like, oh, you look cool, I want to smoke. So maybe that one actually isn't independent, but this definitely would work. And number 4, gotta look at our formula. So, let's start. Number 1, claim. So majority, what does majority mean? It means P is greater than 0.5. Counterclaim. P is less than or equal to 0.5. So then H naught, P is greater than 0.5. H1, oh, sorry. Haha, tricked you. I didn't mess up. Good, it's equal to, because it's always equal to. And then H1, or HA, excuse me, would be that it is greater than 0.5. So we can use our P naught from H naught. So 71 times 0.5 times 1 minus 0.5, and we get 17.75, which is definitely bigger than 10. So we can continue with the problem. Number 4, what kind of test are we doing? We're going to do 1 prop z-test, because we're testing for a proportion. So P naught comes from H naught, 0.5. X, this is the number of successes. So it says the majority of people are smoking after treatment. So how many people were smoking after treatment? We see in this case it's the 39. N, we already said, was 71. And then our statement comes from HA, the alternative hypothesis. So it's greater than P naught. When we type all that into our calculator, our test stat, we should see that our test stat is 0.83. Step 5, p-value. So our p-value, it should also tell us that it's 0.2031. Step 6, significance level. So again, this time it did not tell us a significance level. So what do we assume it to be? 0.05. Step 7, p-value is bigger, so we failed to reject. Right? It is 20% way too big. That's definitely not unlikely. So then there was not enough evidence. So there was not sufficient evidence to conclude that. So let's look at what we're trying to conclude. P is greater than 0.5, which is the same as the claim, so we can just rewrite the claim, right? That the majority are smoking a year after treatment. Or therapy. Okay. So, based off this study, does nicotine patch therapy appear to work? So, let's think about this. If you are using the patch therapy, right, you are trying to quit smoking. So a year after, do you want to be smoking? No, right? A year after, you do not want to be smoking. So again, we would expect less people to be smoking after if it's working, right? So less than half, hopefully. But since it was a competitor, right, they were hoping that more than half would be smoking, which is where the majority are smoking after a year, right? That's what they were trying to show. Cigarette company, they wanted to discredit it. But we concluded that there is not sufficient evidence to conclude that the majority of people are smoking a year after therapy. So they were trying to discredit it. And so essentially what happens is we haven't proven that it works, but we can't disprove it, right? So basically, there's not enough evidence to discredit the nicotine patch therapy. Right? That's what we concluded. We said that there is not sufficient evidence to conclude that there is a majority, that the majority are smoking. So since the majority can't be smoking, or we can't prove that the majority are smoking, right? There's not enough to discredit it. So maybe it works or maybe not. We would have to do another test to figure that one out. All right. So if you have any questions, that's it. Let me know. Feel free to email me or text me. Otherwise, have a great day.